Live. Okay, so I think the first part's easy. Let's go ahead. Today's date is December 13th. Okay. And we're basically going to be talking about polygons today. But the hard part for us will be area and perimeter. That's going to be the hard part, but we're going to figure it out, okay? Boys, will you guys sit down and stop talking? I'm trying to record, honestly.
Rowan is distracted.
I'm trying to teach, okay? I will find a pencil for you, okay?
Be a math break.
Not right now. Here. All right. So, I've already wasted a good minute. Number one. So, obviously, this is a convex, and we're going to call it a quadrilateral. It is a parallelogram, but we're not sure if it's a parallelogram. Okay, 4 sides. It might be a parallelogram, but we're not sure. We're not given enough information, but it certainly has 4 sides, okay? Concave got kicked in. I think it's a hexagon. 1, 2, 3, 4, 5, 6. Concave, because it got kicked in. Hexagon. Okay, now that's easy stuff. The hard part for us today is going to be this perimeter and area, okay? So let's take a look at example 3. And if you have graph paper, great. If you don't have graph paper, follow along. But I'm going to graph this one and take a look at it and see what's going on. So the quadrilateral PQRS, all right? And I want to graph it, so I'm going to put P at 2, 4. Put Q at 2, 3. R at -2, -2. And S is at -2, 3. Okay. Now I'm going to go through this slowly. If I want the perimeter, this is R, P, Q is here, Q is there, and I'm missing S. Okay. So the easy sides, PQ, I'll highlight it so you can see what I'm doing. PQ is this side right here. We can just count that. We just use our eyes and realize the length of PQ is 1. It's pretty easy. Let's get the length of RS. Again, that's pretty easy. We can just count that, okay? We're going to count SR as 1, 2, 3, 4, 5. Now, the other ones are at a diagonal, so you can't really count it because it's at a diagonal. It's not 1, 2, 3, 4. It's longer than that, right? It's longer than 4. So what we're going to do is this. We're going to create a right triangle, because I know how to do the Pythagoras Theorem. So I'm going to create a right triangle right here. Everybody see my right triangle? I have a right triangle right there. And if I wanted to find PS, I'm going to use Pythagoras Theorem. So I'm going to go, and I see a right triangle right in there. 1 and 1, 2, 3, 4, right? So if I just took this triangle down here like this, it's really going to be 1 squared plus 4 squared equals c squared, right? Pythagoras Theorem. So I'm going to go, okay, 1 plus 16 equals c squared. I get 17 equals c squared. And I'm going to use a calculator and round to the nearest tenth. Nearest tenth is good enough. So what is the square root of 17? So on my fancy calculators, my square root button is in blue, so I'm just going to go square root 17. And as a decimal, about 4.1. Now, I also need to find one other length. And the other length I need to find is going to be this RQ, and I'm going to make another right triangle here, okay? And so this right triangle is going to be, let's see, so if I want RQ, 1, 2, 3, 4, 1, 2, 3, 4, 5. And again, to find that length, I'm just going to use Pythagoras Theorem. A squared plus B squared equals C squared. So I'm going to go 4 squared plus 5 squared equals C squared, right? I'm just doing Pythagoras Theorem, which we know how to do. I assume they taught you that in middle school. 16 plus 25 equals C squared. 16 plus 25 is a 41. I need to take the square root of that. And what the square root of 41 is, I'm not sure, but that's where I use my calculator. Square root of 41. I can answer about 6.4. Okay, now, if I wanted to find my perimeter, I'm just going to add them all up. I know that this side is 5, this side is 1. I now know this is 4.1, and I now know that this side is 6.4, right? If I add all the way around, I just found the lengths. So we'll go 1 plus 5 plus my 6.4 plus my 4.1. And I'll just use my calculator to get those answers. Okay, 1 plus 5 plus 6.4 plus 4.1. And I get a perimeter of about 16.5. About, because I rounded. Okay? So if you can do the Pythagoras Theorem today, you can do this, right? Okay? If you can't do the Pythagoras Theorem, sorry, you should have learned that in middle school. Agreed? Okay. All right, now let's take a look at the next example, okay? I'm not going to do the back. We don't need to do the back, but we'll do 4 and 5, okay? Actually, I want to do, you can cross that out. I just want to do this figure here, okay? So let's, on 6, we want the perimeter of square ADEF. So I'm going to go ahead and highlight that so you guys can see which one we're looking at. So we're looking at this. Let's look at the blue square, okay? Okay. Well, again, I'm going to use Pythagoras Theorem. I only need to find one. It says square. So if I find one, I've got the other 4, correct? If I find one length, I've got the other 4. Easy, okay? So I'm going to find a right triangle. Here's a good right triangle right there. You guys see my right triangle? So if I go a squared plus b squared equals c squared, I'll have, let's see, 1, 2, 3, 4. 1, 2, 3, 4. So if I want to find, let's say, length ED, I'm going to go 4 squared plus 4 squared equals c squared, okay? So let's find the length of one of those, and then we've got all 4, okay? So 16 plus 16 equals c squared. And 16 plus 16 is 32. Square root. And I'm not sure what the square root of 32 is. It's 5 point something. I know that. 32. And I can ask about 5.6. We'll just read 5.7, okay? About 5.7. Okay, that's one side. So the perimeter of the square, for number 6, the perimeter of my square is equal to 4 times my 5.7, okay? And I get 22.8, about.
Is this what mainly is going on our test?
Some of it, okay? Now that wasn't that hard, right? If you can do Pythagoras Theorem, you can do this. So back to what I did, I needed this side. I'm very confused, watch. I needed this side. So I knew I could get a diagonal line by making a square. So I've got my right triangle, 4 squared plus 4 squared equals c squared. When it got done, this length was about 5.7. Then 1, 2, 3, 4, and it says it's a square, so I know they're all equal, right? So I multiplied that by 4, and now the perimeter of the square is about that, okay? Now the perimeter of triangle A of BCD, BCD, okay? Now, this one's actually not that hard because we've got some of the information. So let me turn the whole thing upside down on purpose, okay? All right. So this one's not that hard because I know in a triangle, I'm writing it upside down, I know, in a triangle, my area is 1/2 the base times the height. Well, I can just count the base, can't I? It's straight across. So the base is, let's see, 1, 2, 3, 4, 5, 6. Times the height. Let's see, I can count that too. 1, 2, 3, 4. Oh, perimeter. Shoot. Doggone it. I guess you need to stop me. I'm finding the area, which I'm going to have to find eventually, okay? Let's come back to this. My bad. My bad. My bad. Perimeter of ABCD, okay? So, the perimeter of this triangle, I already know this side. I'm sorry, I messed you up. I know this side, don't I? I know that side, it's 5.7. Plus, I know this length, we just counted it, right? 1, 2, 3, 4, 5, 6. Plus, now I don't know this length, but again, I can make another right triangle to find this length. All right, I can do that. Okay, I'm going to get another color up here. Okay. Again, do you guys see a right triangle? I just made a right triangle right up there. So if I want that length, I'm going to go ahead and I'll put the work up here. I'm going to go 2 squared plus 1, 2, 3, 4 squared equals c squared for the length of DC. 4 plus 16 equals c squared. 20 equals c squared. Square root of 20, I'm just going to use my calculator. 4 point something, I'm sure that, about 4.5 maybe. 4.5. Okay, so what did I do? One more time, since I started working on the wrong problem. So what I did was this triangle. I know that length's 6. I already found this one earlier, right? Already found that one as 5.7. I just found this one, which is 4.5. So add that together. Make the perimeter of the triangle. Okay, not too bad. Okay, so we'll just add them up. 5.7 plus 6 plus 4.5, and I get an answer about 16.2 for that perimeter. Okay. Now, 8's going to be pretty easy. 8 is the area of the square, so I'll put 8 down here. How do you find the area of a square? And we know the length. We found the length, didn't we? We found the length of the square. The length was this length, which was 5.7. So the square area is just going to be my 5.7 times my 5.7, right? So 5.7 times 5.7. And again, it's an approximation. 32.5 about. And that'd be in terms of units squared. Okay, here's the area of my triangle, which I was working on, okay? But I'll wait for you guys to get caught up. Everybody caught up? I don't want to flip my page until everybody's got it. Thumbs up? Okay, so I was working on the area of the triangle because I got ahead of myself. So here's my triangle, right? 1/2 base, which is 6 times height, which is 1, 2, 3, 4. Half of 24 is 12 units squared, okay? Now finally, the perimeter of this pentagon, okay? I'm going to flip this around, we'll be done. I'll be done in just a second, okay? All right, let me highlight the darn thing so we can see what we're looking at, okay? All right, we were looking for this figure here, ready? Looking for that perimeter, okay? All right, so I know all those pieces. I just have to put them together. All right, so I know, the area of the perimeter. All right, I'm ahead of myself, area. So the area, we know the square plus the triangle, right? So it's just the square plus triangle. The square we found was 32.5, and the triangle we found was, triangle's way up here, 12, which makes a 47.5 units squared. All right, so today, a little bit harder, but you guys can do this, I think.